Hi, everybody. This is Mr. Youngren, and you are watching your last video for Algebra 2. So congratulations on making it all the way through. We do have one more, followed by the review, and then a test to finish off the quarter. So let's not waste any more time. Let's get right into it, where we're going to be solving log equations. And this is on page, I know it's cut off here, but 211. And as always, we're going to go ahead and have you just get started by working through the opener. And even though this is what we're doing, why don't you see if you have an idea of what you might be able to do? In fact, if you look here, log base 3 of 81 is actually equal to a number. So either using the change of base formula, or if you have one of those fancy calculators that just gives you the log in general, you might be able to figure out exactly what that number is, which makes the equation really easy to solve. So go ahead and hit pause, try to work your way through this. I'll have the answer for you here in just a moment, and then we'll go through the rest right after. Okay, well, that was actually should have been pretty quick. And like I said, log base 3 of 81 is equal to a number. So I was like, all right, let's take that to the side. Let's do some side math. So I end up doing that quite a bit, actually, where I just take something from an equation, move it over. And so what is that equal to? Well, I'm just going to call it x for now. It's not the same x in this equation. I'm just saying, what is log base 3 of 81 equal to? Well, I know if I put it equal to something, now I can do that conversion from log to its corresponding exponential. And so this is really 3 to the power of x equals 81. And so then I'm like, oh yeah, I can check, is 3 to some power 81? And sure enough, that power is 4. So log base 3 of 81 equals 4, which now makes the equation 4 equal to x minus 4. And all I need to do is add 4 and get x equals 8. And we are done. So that's really all that we're going to end up doing. If we can just get it to be a number, we'll go ahead and do that. If not, we're going to have to isolate and convert it to an exponential. And that's what these steps are shown. So when we're solving logs, first step is to isolate the logarithm. In this example right here, that would be the entire log base 4 of x plus 2. And so to isolate that, I need a minus 2, giving me log base 4 of x plus 2, which equals 2. And I got that by just subtracting 2 from both sides. So then, once we've isolated a log, now we're going to use the inverse and write the corresponding exponential equation. So remember, I keep the base the same. So instead of this being 4 to the power of x plus 2, it's 4 to the power of 2 equals x plus 2. And 4 to the power of 2 is a number, right? That's 16. And it equals x plus 2. And so all that I'm left to do is subtract 2 and get 14 as our final answer. So really not much to it, right? It's a very similar process to what we were doing back with exponentials. Okay, so let's do, why don't we do, number 1 is just like the opener, and 2 is just like what I just showed you. Let's call it good at that. So these are 3 that maybe you'll work on with your teacher. If you want to hit pause and work on them right now, that'd be a great idea as well. But let's actually flip the page over and go through just what happens if we have more than one log? Well, first off, we need to make sure the bases are the same. So if the bases weren't the same, we'd have to get a little creative with how we're going to solve it. Luckily, in this case, all the bases are the same, so we're good to go. So it says condense each side of the equation to a single logarithm. So think back to all those log properties that we learned a couple of videos ago and how we can take multiple logs and bring them together. Well, I see that I have 2 logs that are being added, and I know that adding corresponds or is friends with multiplying. So I'm going to rewrite this as log base 7, and then of 2 times x minus 3, and that equals 5. Now, since I'm having to do 2 times that x minus 3 because, right, we're multiplying both terms for what we're taking the logs of, I am going to have to distribute this 2 to both terms. And so this is really log base 7 of 2x minus 6, and now it equals 5. So we've condensed our logs. It now says if we only have to condense one side, then we'll be in the same situation as before, meaning just like we did on the last time, and let's do that now, right? So now I can use my corresponding exponential. So this is 7 to the power of 5, which equals 2x minus 6. And I can go ahead and solve. 7 to the power of 5 is going to be a large number, like 1,600 or 16,807. equals 2x minus 6, where I can easily subtract 6 and divide by 2. I get 5800.5, and we're done. So really nice if we can go ahead and get those logs, or if we can get the log condensed, very simple, just convert it to an exponential, and we're on our way. All right, let's go through one that is talking about this situation here. So if we have to condense both sides, so that we have log base b of m equals log base b of n, then this means that we can just take what we're taking the logs of and set those equal to each other. So what do I mean by that? Let's look at number 6. So 4 and 5, I'm going to leave for you to either do in class with your teacher, or maybe you can hit pause and work on them right now. And we're going to do 6, and that'll be the last problem we cover in your videos for Algebra 2. So we want to stay on one side of the equation. So I'm going to work on just this left side here. And I'm thinking about, what do they condense to? Well, this is subtraction. So I really have log base 5 and then of x plus 4. And we know that subtraction leads to or is friends with division. So I want to take the first log and divide it by the second. So x plus 4 divided by x minus 2. And that equals, well, now on the other side, we need to condense this in the exact same way as what we just did. So I need to take log base 5 of x plus 5 and keep it as base 5. And then once again, I have subtraction, so I'm needing to divide the two things that I'm taking the log of, which would be x plus 5 divided by x plus 1. So we've condensed both logs, and there's actually kind of multiple ways of which we can go here, but I like the way that's described in step 3 above. And that's, if we have the logs the same, log base 5, we don't need that part anymore. When we think about what it means to be equal, we just need everything to be the exact same. So we need what we're taking the logs of to be equal to each other. And so we're just going to essentially rewrite this without the logs. And now we're in a place where we can solve these. Now in this situation, this is actually kind of messy. I'm looking at this, I'm like, I've got a fraction equal to a fraction. How do I solve that? Well, we solve it if you have fractions equal to each other by cross multiplying. Now, remember, cross multiplying is really just us undoing all the division. So if I undo dividing by x minus 2, I need to multiply both sides by x minus 2, which is the same thing as me cross multiplying. So after I multiply both sides by x minus 2, I get x plus 5 times x minus 2, because over on this side, they would have canceled out. So really all I did there was multiply those two things together. Notice that I have not done any work from there. I'm going to do the same thing with the other two. So I'm getting rid of the dividing by x plus 1 by multiplying by x plus 1. So that gives me x plus 4 times x plus 1. And I essentially just cross multiplied those two things. So even here, I'm like, okay, this is still messy. I'm still not quite exactly sure where I need to go. Well, now what I want to do is we actually want to FOIL these, or use boxes to distribute them and get it to be some quadratic. So I'm going to get x squared plus, this would actually work out to be 5x plus 5, and it is equal to x squared plus 7x plus 10. And so now we see a quadratic 2 actually in standard form. And if we want to solve this, we need one side to be 0. So I'm going to subtract x squared. After I subtract x squared, those two terms actually cancel, which is really convenient for us. I'm going to subtract 7x, so I have negative 2x. I'm actually going to subtract 10, so I get minus 5, and it equals 0. Well, because those x squareds canceled out, this actually works out pretty simple from here, where I just need to add 5. So I get negative 2x equals 5, and divide by negative 2. And I get x equals negative 5/2. So it looked really complicating for most of the way, but it actually worked out very simple as long as we understand all the properties, right? So being able to condense the logs, recognizing that you need to cross multiply or undo all the division, recognizing that this is a quadratic on both sides, and then FOILing or distributing those terms So you get quadratics in standard form, get one side to be 0, and then solving is pretty simple from there. All right, well, thanks for following along with all of the Algebra 2 teachers. We had fun making these videos. Hopefully you felt that they were useful. Great job this semester. Have a great rest of your semester and a great fourth quarter or summer if you're watching this for your fourth quarter students. And we'll see y'all next year.